Hello, this is a Pulley's question from May 2020 paper, and I'm going to show you how you can get full marks. So as you can see, you have 8 marks in the first part, and you will see that this 3 lines question is not complicated at all. So you have a pulley, and then you have 2 particles hanging. One is for m kilograms and the other is 3m kilograms. The string passes over a fixed pulley. Ball P is held at rest with the string taut and the hanging parts of the string vertical, like in the figure. So ball P is released and the string is modeled as being light and inextensible. That will be the case in all of your questions. The balls are modeled as particles and the pulley is modeled as being smooth and the air resistance is ignored. Using the model, find in terms of m and g the magnitude of the force exerted on the pulley by the string while P is falling and before Q hits the pulley. So first, you have to think what is happening in the pulley. So if you have the pulley here, you have the force of this particle in that way and the force of this particle that way. You know when the pulley is smooth, tension in both sides of the pulley is the same. So we have a tension and a tension here. So those 2 tensions down are going to be the forces acting on my pulley. So I have, and I'm going to draw the forces. So I have a tension pointing down here, T, and another tension pointing down here that will be exactly the same. So the force acting on the pulley will be these 2 tensions together, so 2T. So we need to find the tension. If we see the particle P, I'm going to draw the forces that I have on it. So I have tension pointing up, which is again the same because the string is inextensible, and I have a weight pointing down that is going to be 4mg, so the mass gravity. And in the Q, I'm going to do the same. I have tension pointing up, again is the same value, and I have my mass, my weight pointing down. Those are the forces that I have. So if I want to find the tension, what I'm going to do is to use one of the particles or both. I don't know the acceleration. So that means that I have 2 unknowns, the tension and the acceleration. So I will need to use both particles. I will have simultaneous equations, and when I solve them, I will be able to find T. And if I am asked, I will be able to find A. So when it's released from rest, this one is heavier than this one. So the whole thing is going to move that way. So I have one acceleration down for P. So P is moving down and Q is moving up. So let's go into write the equations of motion for both of them. So I'm an A, and I'm going to write the equation of motion for P first. For example, P is going, we say P is going down, so this force is greater than this one. So I'm going to write this one first. So it's 4mg minus T is going to be mass acceleration. Yeah, remember, so I'm applying this. Force is mass acceleration. So the sum of forces, the resultant force is 4mg pointing down minus the tension pointing up is going to be the mass of the particle, which is 4m, times by the acceleration. And for Q, I'm going to do the same, but Q is moving up. Q is moving up, so this one is going to be greater than this one. So I'm going to write T minus 3mg is the mass acceleration. So T minus 3mg is going to be the mass 3m acceleration. The acceleration is the same because the string is inextensible, the pulley is smooth, and and that's it for those reasons. Sorry. So I have 2 equations with 2 unknowns, A and T. So if I solve them, I will be able to find A and T. I know I don't have to find A, but I think to solve it is much quicker if I find A. So if I add both equations, I will have 4mg minus 3mg is mg, T and T are cancelled, and I have 7ma. Therefore, A is going to be g over 7, and then I can substitute in either the top or the bottom one. So if I substitute the acceleration, let's say here, T is going to be 3ma A is g over 7 plus 3mg. When we do this, we have that the tension is 24 over 7 mg. If the tension is that, I know that the force in the pulley, that's going to write something like that. Force in the pulley is going to be 2T, so the force is going to be 48 over 7 mg newtons. And that's my answer. And this is 8 marks, believe it or not. So I'm going to show you where the marks are. So the first one is to write one equation for PE and for writing it correctly. So the first two. Then another mark for writing an equation for Q and for writing it correctly, substituting in the room with the right signs and everything. Then another mark is for solving the simultaneous equations, so for the method. And another mark for finding the tension correctly. You don't really need to find A, so you don't get any mark to find A. I just found it because I think it's easier to solve equations. And then the last two are one for knowing that the force in the pulley is 2 times the tension, and the other one for your answer. And that's it, that's 8 marks. The last thing is, so B is state one limitation of the model apart from ignoring error resistance that will affect the accuracy of your answer to part A. So remember, we have assumed a few things here. We have assumed the string is light and inextensible, and the balls are modeled as particles. And pulley is smooth, and the air resistance is ignored. But they ask us not to mention their air resistance. So we can say any of them. We can say, for example, that the pulley is not smooth, or the weight of, or we can use the weight of the rope instead of just saying that it's light, or we can say that the string is really extensible instead of inextensible. So either of them will give you the 1 mark. So it could be really something like, considering that the pulley is not smooth. Any of them. So whenever you have to answer how to improve a model or what things could affect the accuracy, just check the assumptions that you've done and just write any of them. It really doesn't matter. Or if you are using the gravity, for example, in your question, in this case, they ask us to write in terms of gravity. But if you are using the actual number, you always can say that you can use a more accurate value of gravity. And that's it. This is just your 9 marks questions about pulley. It's quite simple.